Two isotopes of carbon, C12 and C13, have masses, have those respective masses. Okay, two isotopes are singly ionized, and they all have speed. Okay, then go into region with magnetic field. What will happen? So on and so forth. Okay, what will happen with the charged particle when they enter magnetic field? You should read more about it in the mass spectrometers. So we have, let's say, this is everywhere. Up here is the region, everywhere here is the region where you have magnetic field. You don't have magnetic field down there. Let's say this is the region where magnetic field exists, and this is the let's say that is the number that indicates its strength, 0.7501 or 1 Tesla. That is the magnetic induction, so it doesn't matter. And if we have charged particle that will, this is the direction of magnetic field that is in the paper. If we have a charged particle that will fly into this region, okay, this will be the speed. You have, it is positive charge. What will happen? It will be affected by Lorentz force. That force will be centripetal force and will force this particle to go in circular motion, semicircular, so to speak. That particle will go in here, will rate the semicircle and will hit this screen here. And if we have two identical particles, it will traverse the same distance and so on. But if carbon 12 and carbon 13 are very similar particles, but one has slightly bigger mass than the other, so their paths will be slightly different. So this will be, let's say, path of the one, C12, and path of the 13, let's say, will be slightly bigger. Okay, and in this situation, what we need here, determine the spatial separation between two after they have traveled through a half circle. Spatial separation is distance from here to here. In other words, this is unknown quantity, and that it will be in meter, distance from here to here. Okay, let us now see what have I done to solve the problem. That is not in this. Don't say idiot. This is the one. Where is the solution? Okay. So this is the mass of the C12. This is mass of C13, and their respective speed. They have same speed. Single ionized. That means that they missing one electron. That means that they are positive 1.602 times 10 to the minus 19 coulombs. And you have magnetic field that is determined by 0.7501 Teslas. What will happen here? So we will have centripetal force, circular motion. That means we have centripetal force. Centripetal force is a Lorentz force in this case. This is the equation for centripetal force. You have mass of the object, you have its speed squared, and radius of this circle. And in this situation you have Lorentz force. Centripetal force is the Lorentz force in this situation, so we will place on one side equation for centripetal force and the other side equation for Lorentz force. One speed will missing, and this is the radius of the C12. Similarly, you can derive radius for C13. This is the same electric charge, same speed, just masses are just different. So you will see in this situation that if you have a slightly bigger mass, you will have a slightly bigger radius. And separation is x is difference in a half circle radius, nothing more. You just deduct those two things. They have same speed, same charge, and same magnetic field, so we could all this put in front of the brackets, and inside the brackets you see just that they are figured just the masses here. So you just put in the I just put in the numbers and calculate the spatial difference in meters. Again, what does it mean? This is radius of C12, this is the radius of C13. This radius is calculated down there. This is R12, this is R13, and the x is equal R13 minus R12, and you get some result in meters. If you want to see detailed solution, see the PDF file in the description. If you have some, if this was useful, please subscribe and tell your friends. Bye.